Hey guys, hope everybody's doing okay. What we're going to do is take a look at the answers to a lot of these problem-solving problems, and hopefully, after we go through this, you realize you had a lot of these correct, and if you didn't, you now understand it a little bit better and can do some of these in the future. All right. So we'll start number one. This one goes back to measuring appropriately and measuring correctly. It says Jason measured an object in the room with a ruler and recorded the length to be 45.18 centimeters. Somebody else measured the object, and he got the length to be 50. If both measured correctly, that's key there, both measured correctly, is it possible that they both measured the same object? The only way to, like initially, you're going to say, well, no, like the numbers are clearly different, but you have to think about what is the uncertainty of each measurement. So if you look at the 45.18, okay, the last measured digit here, or the last like certain digit is the 1, okay? Remember, we always estimate one more digit, which in this case is the 8. So over here, I say that 45.18 centimeters is my measurement that was made. What else could it be though, right? Remember that 8 is estimated. So this ruler has a precision of plus or minus 0.01. It could be off by plus or minus 0.01 centimeters. So in reality, we could have a measurement of 45.17, 45.18, or 45.19. Now, if you look at the other measurement, it was 50 centimeters. The 0 is not significant. Okay, that's really, really important. That 0 is not significant. So the last digit that we estimated was the 5. Okay, so we have a situation where it might be something like, it might be something like this, where you have, okay, that's our ruler. Okay, and those are markings on our ruler. You might have the ruler be something like this. You have 0, 100, 200, 300. Maybe you have some instrument where it's like that. And this object, okay, let's say that's the object, right? So the interval goes by 100s, okay? So you have to estimate to one place more precise, which is the tens place. So I could guess that, all right, this is, it's definitely between 0 and 100. I'm going to say 50 centimeters. In reality, it might be 40, it might be 60. So the range is anywhere between 40 and 60 centimeters. What you need to do is figure out, is there an overlap between those two ranges? Is there an overlap with 40 through 60 and 45.17 to 45.19? And there clearly is. Okay, there is an overlap between those ranges. So the answer to this is yes, it is possible that they measured the same object. Okay, if the object was truly 45.18 and this was that object, all right, you'd never be able to tell it's 45.18 using this ruler. So you would say that's either 40, 50, or 60, right? So it could definitely be the same object because those ranges overlap. That's how you want to do the second one. All right, so we'll move this down here and take a look at number 2. Same situation, but we're using an electronic balance. So it says Bill uses the balance to record the mass of a beaker to be 134.06. Sally uses a balance and determines it's 135.0. Both were calibrated properly and they measured correctly. So is it possible they're the same beaker? So what I did was I took 134.06 and I found out what my uncertainty is. So my last digit is estimated. So it could really be 134.06, or it could be 134.05 or 0.07. So I have that over here. And then my other measurement was 135.0. That 0 is significant because there's a decimal place there. So this number has 4 sig figs. That 0 is one of them, okay? So it could be plus or minus 0.1 in either direction. So you're looking at 134.9 all the way through 135.1. If you look at those two ranges, there's no overlap, so it's not possible that we had the same object, okay? So it can't be that same beaker. All right, moving on. Question number 3 is our problem-solving problem. So this one's very straightforward. We have our data table with mass, volume, and density. Okay, you get a point for doing the data table. a point for putting your relevant equation, D equals m over V. You have the mass, you have the volume, so all you have to do is plug them in, and you want to go to proper sig figs. So 30.6 has 3 sig figs in it, 52 only has 2 sig figs in it, so your final answer needs to have 2 sig figs in it. So our final answer is 59 grams per milliliter. Okay, very straightforward question. If we move to question number 4, question number 4 says the density of gold is 19.3 grams per centimeters cubed. What's the mass of 11.30 centimeters cubed of gold? So for this problem, we want to, again, make our data table. All right, so I have my data table of 19.3 grams per centimeter cubed is my density. My volume is 11.30 centimeters cubed. Students get this one wrong every year because they see 11.30 centimeters cubed next to the word mass. And you have to realize it says, what is the mass? So we don't know what the mass is. It says of 11.30 centimeters cubed of gold. So our hunk of gold is 11.30 centimeters cubed. That's why I have that as my volume here. So recognize that 11.30, that centimeters cubed is not a unit of mass. So there's no way you could have put that in for your mass. It has to be volume. Centimeters cubed is a unit of volume. So what I initially had here is D equals M over V, okay? And I showed you how I solved for volume. So you can or how I solve for mass. You can cross multiply, like I showed you in the first video, where I introduced this problem solving. So you can definitely do that. Or you could just, since volume's on the bottom, multiply both sides by V, okay? If you cross multiply, you get D times V equals 1 times M, which is just mass. So there's our equation. So we need to have that, okay? D times V equals M. Plug everything in. 19.3 grams per centimeter cubed times 11.30 centimeters cubed. Both, well, this number has 3 sig figs. This number has 4. That 0 is significant because there's a decimal here. So with 218 grams as your mass, okay? Okay, notice also how centimeters cubed cancels out here because it's on the top right here and it's in the denominator right here. Okay, so that's going to cancel out. You're left with grams. Next question, a little bit more work. It's question 5. Okay, iron has a density of 7.86 grams per milliliter. Could a block of metal with a mass of 18.21 grams, a length in centimeters, a width in centimeters, and a height in meters be iron? And explain. So you have, it's important to label everything here. So you have a density of iron and you have a block of metal. You don't know what that block of metal is. That block of metal may or may not be iron. So some students approach this question and they're like, well, I have everything. I have density, mass, length, and width, and height. So what am I missing here? You have the density of iron. That's a known value. You have a mass, length, width, and height of some mystery material. What you want to do is use that information here, okay? Use that given information of that mystery block of metal and determine the density of that piece of metal. So that involves a little bit of work. In order to find density, which I have down here, I need mass and volume. I have the mass, okay, 18.21 grams. I don't have the volume. I need to find it. Well, how can you find volume with length, width, and height? Well, you can multiply them all together. So notice though, you have a length in centimeters, a width in centimeters, and your height in meters. So that's no good, all right? So what can we do here? We could change our height into centimeters. So we're going to factor label that here, okay? 0.03241 meters into centimeters. We get 3.241 centimeters, all right? Let's plug that into our equation. So volume equals length times width times height. Notice I still have my word formula. That's a requirement, okay? Then I plug my numbers in with my units, and I end up with a volume, 2.56 because I need 3 sig figs because of the 0.861. 2.56 centimeters cubed. A centimeter cubed, if you remember, is the same as a milliliter. All right, so that was from the factor label lesson that you guys watched and that we did. So 2.56 centimeters cubed or 2.56 milliliters. Okay, because our density was in grams per milliliter, which is the same as grams per centimeter cubed. So now I can go down here. D equals m over v. I have my mass. I have my volume now. 4 sig figs with my mass, 3 for my volume. Final answer needs 3 sig figs, 7.11 grams per centimeter cubed. If you did what we did in problems 1 and 2 on this set, and you saw that, okay, this is 7.11 grams per centimeter cubed. What's my range of acceptable densities? It's 7.10 all the way through 7.12, okay? What is my density of iron? It was 7.86. So the accepted range there is 7.85 through 7.87. There's no range that overlaps for these two values, okay? 7.85 through 7.87 doesn't overlap anywhere with 7.10 through 7.12, okay? So the answer is no for that one. All right, number 6, this is just like the practice problem that I walked you guys through when I introduced this material, okay? So you have density of ice, 0.92 grams per centimeter cubed. How much space does 0.5234 kilograms of ice occupy? So this is another one where students don't read it correctly. They see, it says how much space does 0.5234 kilograms occupy? And they think, well, they see how much space here. They're like, oh, that's volume. So that's going to be my volume. The unit is kilograms, which is a unit of mass. Okay? So density, 0.92 grams per centimeter cubed. Mass, 0.5234 kilograms. You'll notice right away that your unit of mass in your density is in grams, and the mass unit that I gave you is in kilograms. So you're going to convert that, factor label it right into grams. We did the exact same thing in that practice problem that I did last lesson. Okay, so we did the same rearrangement of the formula as well. D equals m over v, it's a requirement. Cross multiply, and you get v times d equals m. And then divide both sides by density, and you get your equation of volume equals mass over density, just like we did in the practice problem. Plug your values in, 523.4 grams divided by 0.92 grams per centimeter cubed. You need 2 sig figs in your final answer, because 0.92 has 2 sig figs in it. 523.4 has 4, so you get 570 centimeters cubed, or 570 milliliters, because it's the same thing. Okay, notice I have a lot of work here. So I have my factor labeling to get my new mass. I have my initial equation. I have my rearrangement to get my final equation. Plug my numbers in with units to get my final answer of 570. All right, this is the problem of the day here, number 7. A lot of work for number 7. Okay, let me walk you through it. Number 8's a little bit easier. So for number 7, you have a mass of empty flask, and it wants to know what's the mass of the flask when filled with acetone. Gives you the density of acetone. The same flask weighs 75.2 grams when filled with water. Okay, it gives you the density of water. So on the surface, it seems easy. You want to know the mass of the flask with the acetone in it. Well, we have the mass of the flask already. All I need to do is find the mass right here, the mass of my acetone, to figure out what it is, because I could take the mass of my acetone, add it to the mass of the flask, and get the mass of the flask with the acetone in it. Okay, seems pretty easy. How do we do that though? I need to get the mass of acetone somehow, but if you try to figure it out, there's no direct way to do that. What we have to do then is work through water, okay? So I drew a little picture here. All right, I don't know if it'll help or not, but you have a flask with water in it, okay? So what you can do then is recognize that like water is a liquid and so is acetone. And the volume is definite for liquids, right? So let's pretend there were 50 milliliters of water in that flask. Well, that means there's 50 milliliters of acetone in the flask, okay? If the flask could hold 50 mils of water, it can hold 50 milliliters of acetone. So if we could figure out the volume of water, we could then assume it's the same as the volume of the acetone, okay? Because they're both liquids, all right? So we're going to use the information for water to get acetone's information. So let's take a look at how we do that then. I have the mass of water equal to the mass of the flask with the water in it, which I'm given right here, okay? Minus the mass of the flask. So flask and water minus flask gives me just the mass of the water. So I plug my numbers in, okay, word equation, numbers with units, answer with units to proper sig figs. It's a subtraction problem, so we go on decimal places. 1 decimal place here, 2 decimal places here, 1 decimal place in your final answer. Okay, so 25.5 grams of water. What can I do with that? Well, I could take the density of water, the mass of water, and find the volume of water. Okay, so I shortened it up because I had like no space. Sorry about that. The density of water is mass of water over volume of water. Rearrange it like I literally did up here in this problem. You're going to have the volume of water equals mass of water over density of water. So 25.5 grams over 1 gram per milliliter, because that's the density of water from right there. And I get a volume of water equal to 25.5 milliliters with 3 sig figs in it. That's the volume of acetone, right? Because again, if I could fit 25, or let's see what it is. Yeah, if I could fit 25.5 milliliters of water in that flask, I could fit 25.5 milliliters of acetone in the same flask. Okay? So now I have my volume of acetone, 25.5 milliliters. Now I just go and I use my density of acetone equals mass of acetone over volume of acetone. And I can figure out that I can rearrange it and get mass equals density times volume. I would cross multiply this to end up with this. Plug your numbers in, 3 sig figs, 20.2 grams. Final answer, mass of flask and acetone is mass of the flask plus mass of the acetone. Add them up, 1 decimal place in my answer because it's an addition problem. So I get 69.9 grams of acetone. Okay, that takes care of problem 8, or problem 7. On to problem 8 for the last one. Let's take a look at it. A piece of metal is found in the chem lab. All right, sounds safe. The mass of the metal was measured with a balance to be 4.89 grams. Here's my mass. Using water displacement, you get a volume of 0.6 milliliters. If the density of cobalt, right here, density of CO, bad handwriting, not Cu, it's CO, density of cobalt, 8.90 grams per centimeter cubed, which is the same as grams per milliliter. Could our metal be cobalt? So all you want to do is compare the two densities. So density is mass over volume. Have to have that. Plug your numbers in with units. 4.89 grams of our mystery metal over 0.6 milliliters of our mystery metal, which is the same as 0.6 centimeters cubed. 1 sig fig in your answer, right? That's it. So you do 4.89 divided by 0.6, you get 8 grams per milliliter, or 8 grams per centimeter cubed. Based on what we did in problem 1, 2, and 5 in this set, your true answer, since this is the only digit, your true answer could be either 7, 8, or 9 grams per milliliter. Okay? So that's important to recognize that this is obviously not 100% certain because we had some error, potential error in finding this. We have that uncertainty, right? 4.89, that 9 is the uncertainty. The 0.6, that's the uncertain digit, right? It could either be 0.5, 0.6, or 0.7. So when we get our final answer, you recognize that this has to be this has to have some leeway to it as well. That's how we get 7, 8, or 9, since there's only one sig fig here, okay? So you want to ask yourself, is 7, 8, or 9, like that range between 7 and 9, does that overlap with 8.90 grams per centimeter cubed for the cobalt? So 8.90, that 0 is significant, so it could be uncertain to that hundredths place. So this density could be 8.89, 8.90, or 8.91. Clearly overlaps between 7 and 9. So yes, density, or yes, this mystery metal can potentially be cobalt, because we were so limited with this, okay, and the graduated cylinder that we used. That one sig fig kind of limits us all the way through to give us a very broad range of answers here. All right, there's a question on your test like this. We did, there were a couple throughout the assignment here with those in it, that style. So hopefully we understand that and we're used to it. If you still have issues, make sure you talk to me in class or let me know, and we'll take it from there. All right, guys, that takes care of the homework set. See you later.